inverses. 3.3 day number 3. These two are not inverses. Let's not be fooled. Y equals 1 over x and y equals x over 1 are not inverses. No, not true. No. Okay, not true. Fail. How do we find an inverse? We're going to talk a little bit deeper on this in a moment. But what you do is you take a function. Let's come up with just a linear function. I want Steiger. What are your 2 favorite numbers? If you got it. Okay. Ben's favorite numbers are 6 and 11. That is an equation of a line. In order for me to find the inverse of that function, what I'm going to do is I'm going to switch x and y. And here's why we're going to do that. Because inverses, okay, let's say we have f of x, and it has a domain, and it has a range. Okay, f of x has a domain and range. What's cool about inverses is that the inverse of f, its domain, is equivalent to the original's range. And its range is equivalent to the original's domain. So what we did was we switched the, what? X's and the Y's. Oh, sick. So in this case, it's kind of trivial because what's the domain of a line? All real numbers. What's the range of a line? All real numbers, as long as that line isn't horizontal or vertical. So I'm going to find the inverse by solving for which special variable up here? Y. I'm going to add 11. And I'm going to divide by 6. Okay, so x over 6 plus 11 over 6. Cool. So inverses. Here's a really cool fact. Slope of f of x, this function, was 6. Slope of the inverse, okay, Joey, you're going to say, I told you. Not necessarily, but the slope of that is 1/6. So if you ever deal with lines, the slopes will be reciprocals. Okay, but the function itself won't be a reciprocal of the original. So the domain of our inverse is equal to the range of the original, and the range of the inverse is equal to the domain of the original. We just swap them. Okay, so I want to talk about a special function. I want to talk about that function right about meow. Okay, here's the function. Y equals x squared. Cool. What is the domain of this function? All real numbers. Okay, so the domain of this function is all reals. What's the range? From 0 up to infinity. So if this is true, and I find the inverse of this function, what should the domain of the inverse be? 0 to infinity. And the range should be all reals. Let's test that. Okay, here we go. Y equals x squared. I take and I reverse these. So x equals y squared. Okay, what I'm going to do is I'm going to take the square root of both sides. If I take the square root of both sides, does y equal the square root of x? Yes, but what else does it equal? The negative square root of x. So let's sketch this. Square root of x. Well, square root of 0 is 0. Square root of 1 is 1. That point is shared, right? Because 1 squared is 1, and so is the square root of 1. That is the square root of x. What would the negative square root of x look like? Same thing reflected. Let's say this is the point for -2. Let's flip these around and let's find that point. -2, 4. Oh, -2. Oh. Sick. Chow. Okay, how about this point? Let's think of a point. Oh, this is the point 25, comma 5, right? Square root of 25 is 5. Oh, well, let's flip them around. 5, comma 25. Sick. Cool. So all we've done is switch the x's and the y's. What is the domain of this new function? 0 to infinity. What is the range? All real numbers. Okay, that's a special classic example of inverses. We took a brief pause there to take care of some things. Let's move on. So here are the requirements of an inverse. First of all, your original has to be a function 1-to-1, has to pass a vertical line test. Second of all, the domain of the original is now the range of the inverse. Same with the domain of the inverse, now the range of the original. Sometimes it's easier to not try to find the domain of the inverse. Rather, just take the range of the original and use that. Blah, blah, blah. We kind of did part 3 already. And inverse functions can be drawn by reflecting f about the line y equals x. Cool. Guess what? Doesn't this graph look like it might be a perfect reflection over this line? Yeah, sick. That's the line y equals x. Let's continue. Let's go ahead to this page. We have already done this first example here. This is f of x equals x squared, and we found f inverse of x to be plus or minus the square root of x. Okay, that's just confirming the same thing. Okay, here's another linear example. I bet you, Joey, I bet you the slope of this one and the slope of this one, they be reciprocals, right? If this slope was 2, this slope will be half. All right, it's consistent. Only with lines, though. All right, here you go. That's cool. Oh, the slope's 1. Slope equals 1. Well, what's the reciprocal of 1? Oh, that's 1, sir. It's just a shift down a certain number of units. Ah, that's amazing. Okay, I'd like for you to take a moment and to graph the inverse of each of these functions by using what you know about x and y. All right, go. Sound on. There you go. Graphing inverses should be very nice. You should take your x's and y's, switch them. When in doubt, go ahead and draw yourself a line y equals x, and just go ahead and see if eyeball it. Does it look decent? That one's okay. I think this was my, oh, that wasn't good. But this was probably my varsity option here. Yeah, that looks pretty dang good, other than that purple line. Terrible. Okay. This should be cash money in the bank. Just deposit that $10 an hour you're getting at Potbelly and just cash it in. Right? Is it $10 an hour now? Are you still getting? Nice. That's what I'm talking about. Embrace it. An hour for an entry-level job? $15 an hour. Oh yeah, they're making you think they're doing you a favor. Your $15 an hour is really $10 an hour after tax anyway, so it's cool. About a third of your income goes toward. Pause this. Here we go. Let's keep going. Let's look at. This is cool. I don't really care. Let's look at something like this. G of f of x. I'm going to kind of cruise through this because I'm going to run out of 15 minutes real quick. But I'm going to plug f of x into g of x. So I'm going to take g of x, right, which is something plus 3. I'm going to plug f of x into it, 7 minus 2x. I'm going to simplify. So it looks like g of f of x is, what would that be, negative 2x plus 10. Yeah, That's g of f of x, as long as I didn't screw anything up. Somebody tell me if I did. Let's find the inverse of g. Well, g is x plus 3. So instead of y equals x plus 3, I'm going to write x equals y plus 3. I'm going to solve for y, so it looks like y equals x minus 3. So here's g inverse of x, which is equal to y, which is equal to x minus 3. Now let's find f of g inverse of 5. So far, so good? So g inverse of 5, let's first do that. G inverse of 5 will be x minus 3, right? That's g inverse, but I'm plugging a 5 in there, which gives us g inverse of 5 equals 2. Now, if I take f of g inverse of 5, I'm really taking f of 2. So let's find f of 2. F of 2 be 7 minus 2 times whatever our input is, and in this case, it's 2. So f of g inverse of 5, f of g inverse of 5 equals, nope, not 2, 3. All right, 7 minus 4 is 3. All right, I think at this point we're all pretty comfortable with lines. Let's get to something funky. For right now, I'm not going to do this one. I want to get to this one. This one's going to be fun, right? We got to complete the square first. In order for me to get it in this form, x minus a quantity squared plus b, I got to do some work. So let's do that. Let's take our function f. So f of x equals x squared plus 6x, minus 6x plus 13. And I want to put it in the form, what we call a vertex form. Okay, so I'm going to switch x and y. I'm going to say x equals y squared minus 6y. I'm going to leave some space here. And I'm going to add 16. Now, I'm going to leave space for what I'm going to, is it 13 or 16? 13, good job. Okay, and just anticipating, I'm going to also subtract that thing off the end because I'm adding something new into the function. I don't know what that creepy cartoon is for there, but, and that kid, what the heck is with that kid? Oh, they're pointing at us and laughing because we have to complete the square. That's what they're doing. Yeah. Ha. Real funny, kid. Real funny. Okay, so completing the square, what do we do with this number, negative 6? We divide it by 2. You guys sound like you've done this before. Divide it by 2, I get negative 3, but negative 3 squared is 9. So I'm going to put 9 in on both ends here. Now, why would I go and do that? Well, because now I can write this thing as y minus 3 squared. If you FOIL that out, you'll get y squared minus 6y plus 9. Out here, I've got 13 minus 9, which is 4. This allows you to find the inverse. So I'm going to subtract 4. This kid's leaving. They don't even care. Okay, I'm going to take the square root. What's going to happen here, though? If I take the square root of both sides, I get a plus or minus. And I get y minus 3. Now, the last step is to take and to add that 3 out here. This is our inverse. Now, there is a precursor up here. They've set the domain x greater than or equal to 3 for the kids. Okay, part A ended here. All right, I wrote it in vertex form. Part B ends here. All right, this is my inverse. This is f inverse of x. Let's pause for a second. All right, you guys, we just paused the video, but the range of the original function f is going to be equal to the domain of the inverse. because of the smiley faces. Oh my gosh.